Hello everyone, myself Rajale and Shamsundar. I am from RBNB College, Sri Rampur. My subject is mathematics. In today's lecture, we go with the concept of the chapter matrices. In that, we are going to see some examples, some important examples related with inverse of matrices. Okay, let's go with our example. Here in example, we consider find the inverse of the matrix. Here given matrix is having two rows. In first row we have 1, 2, and in second row here 2 minus 1. Okay, so this is the given matrix having order 2, that is having 2 rows and 2 columns. Let us consider this matrix as A. Consider here matrix A as here in first row 1, 2, and in second row 2 minus 1. Now in next step we see here inverse of matrix is exist or not, and to check this we consider determinant of given matrix A. Okay, so here determinant of given matrix A is denoted by using the notation like this. Okay, then inside the two vertical bars we have the elements here 1, 2, 2 minus 1. Okay, now this is equal to, here we have, here 1 into minus 1 is minus 1, then with minus sign, here we have 2 into 2, we know 2 into 2 is 4, and this is equal to here minus 5. So here we get determinant of A is equal to minus 5. Here this determinant is not equal to 0, so we say here inverse of given matrix A exists. Inverse of given matrix A exists. Okay, now we have to find the inverse of matrix by using the elementary transformation. Firstly, we go with the row transformation. If we have to use row transformation to find the inverse of given matrix A, here we consider the equation. Here A inverse is equal to I. Here I is the identity matrix having the order like matrix A, that is having order 2. Okay, so here we replace our given matrix A by using elements here 1, 2, 2 minus 1 into A inverse. This is equal to, now we know your identity matrix of the order 2 and is having elements 1, 0 and 0, 1. That is 1, 0 in first row and 0, 1 in the second row. Okay, now to find the inverse by using the row transformation, here we reduce this matrix A into the identity matrix. And like this RHS and the having elements here 1, 0 and 0, 1. Okay, so here to reduce the given matrix A into identity matrix, we use some transformations. Okay, here in the position of A1, 1. Remember, this 1 is in the position of here A1, 1, that is in the first row and in the first column. Okay, so here we want 1 like this. Now in the next step, here in the position of 2, we want 0. That is, we have to reduce this 2 to 0 by using the transformation. Here remember, we have to perform the transformation on row second since this 2 is in row second. Okay, and transformation is here R2 minus 2R1. That is, we multiply each element of the row first by 2 and we subtract this from here elements from row second. So here in the matrix We keep our first row as it is. So in the first row we have 1, 2. Then in the second row, here change is in second row and change is. Here remember, first element from the row second is 2. Then with minus 2, here first element from this row first is 1. So we replace R1 by using 1 and we get here 2 minus 2 and we know 2 minus 2 is 0. So here in the position of 2 we get 0. Next, now in the position for the position of the second element, here second element from row second is minus 1. Then with minus 2, here second element from first row is 2. So here 2 and is equal to, here we get 1 minus 1 minus 4. We know minus 1 minus 4 is minus 5. So in the position of minus 1 we get minus 5. Now remember, here transformation, that is we perform the transformation on only prefactor, that is only on A, not on A inverse. And we perform the same operation, we perform the same transformation in RHS also. In RHS also. So here we keep A inverse as it is. Now this is equal to, here inside the matrix. Okay, now we perform the same transformation, that is same operation. Here we keep first row as it is. So 1, 0 as it is. Now change is in row second and change is. Now remember, here first element from row second is 0. Then with minus 2, here first element from row first is 1. So we replace 1 and is equal to, we know 0 minus 2 is here minus 2. So here in the position of 0 we have minus 2. Next, here for the second element of the row second, here 1 is given. Then with minus 2, here second element from first row is 0. So 2 into 0 and is equal to, we know this is 1 minus 0 and we know this is 1. So we replace this 1 by using here again 1. Now here we have to reduce this minus 5 to 1. Remember, here identity matrix is like this. Here in the position of A to 2 we want 1. That is for the position of minus 5 we want 1. Now to make this 1 we divide each element of row second by minus 5. So here change is in row second and change is here row second divided by minus 5. Okay, so here inside the matrix, here first row, we keep first row as it is, that is this 1, 2 as it is. Then for the second row, we divide each element by minus 5. We know 0 upon minus 5 is 0. We know minus 5 upon minus 5 is also here 1. Okay, next, here we keep A inverse as it is. Now this is equal to, here in RHS again, we keep our first row as it is, that is 1, 0 as it is. Then change is in second row. And here we divide each element by minus 5. So here minus 2 upon minus 5 is 2 upon 5. Then 1 upon minus 5 is here minus 1 upon 5. Okay, so we reduce this minus 5 to 1. Now here in the next step, we reduce this 2 to 0. Since in the position of A, 1, 2, we want 0. So to make this 0, here we perform transformation on row first, and transformation is, here remember, here R1 minus 2R2. That is, we multiply each element of row second by 2 and we subtract this from here elements of row first. Okay, so here in the first row, now we consider some calculations. Here in the first row, first element is 1. Then with minus 2, here first element from row second is 0. This is equal to, we know 1 minus 0 is 1. So in the position of 1, here we have 1. Next, here second element from first row is 2. So 2 minus. Now here we consider second element from row second and is 1, and we know here 2 minus 2 is 0. So in the position of 2, here we have 0. Now we keep our second row as it is, here 0 1 as it is, into A inverse is equal to. Now in RHS again we perform the same transformation. Okay, so here in the matrix again, here first element from row first is 1, then with minus 2, here first element from row second is 2 upon 5. So here in the bracket 2 upon 5. Now we know here 1 minus 4 upon 5 and is here 1 upon 5. So in the position of 1, here we have 1 upon 5. Next, for the second element, here second element from row first is 0. Then with minus 2, here second element from row second is minus 1 upon 5. So here we get 2 upon 5. So in the position of 0, here we have 2 upon 5. Now we keep second row as it is, here 2 upon 5 and minus 1 upon 5 as it is. So we reduce this matrix A to identity matrix. If you reduce this to identity matrix, we get a form here I into A inverse and is equal to, inside the matrix, here we have elements 1 upon 5, then 2 upon 5, next here 2 upon 5, and last element is minus 1 upon 5. And we know here I into A inverse is A inverse and having elements again here 1 upon 5, 2 upon 5, 2 upon 5, and in last here minus 1 upon 5. So this is the inverse of given matrix A, and we find this inverse by using elementary transformation, that is by using row transformation. Okay, so very simple example. Let's go with second example. Here again we have to find the inverse. Here again we have to find inverse. Okay, here given matrix is having elements in first row 0 1 2, for second row 1 2 3, for third here 3 1 1. 3 1 1. Okay, now here we consider given matrix as A. So A is equal to, inside the matrix here we have 0 1 2, then 1 2 3, in for last row here 3 1 1. Okay, firstly we check whether inverse of given matrix is exist or not, and to check this we consider determinant of given matrix A. Okay, so here determinant of A is equal to, inside the two vertical bars here we have the elements. So 0 1 2, 1 2 3, then 3 1 1. We have to find this determinant. Okay, so here determinant of A is equal to, now to find the determinant we consider our first row. Here first element from first row is 0. So 0 inside the bracket. Now we eliminate our first row and first column, since this 0 is in first row and in first column. So we do calculation on remaining elements. Here we know 2 into 1 is 2 with minus sign. Here 1 into 3 is 3. So again with minus sign, here second element from first row is 1 into bracket. Here position for this 1 is your first row and is in second column. So we eliminate first row and second column. Here calculation is in remaining elements. Okay, so 1 into 1 is 1. Next with minus sign, here 3 into 3 is 9. Okay, next with plus sign. Here last element from first row is 2. So 2 into bracket. Here the position for this 2 is in first row and in last column. Okay, so here calculation is in remaining elements. Here 1 into 1 is 1 with minus sign. Here 2 into 3 is 6. Okay, now this is equal to here 0 into minus 1, then minus 1 into minus 8. Next here plus 2 into, we know 1 minus 6 is minus 5. So here minus 5. Now this is equal to, we know 0 into any number is always 0. Next minus 1 into minus 8 is plus 8. Then here 2 into minus 5 is minus 10. And lastly here we get minus 2, and we know here minus 2 is not equal to 0. If determinant of A is not equal to 0, then we say here inverse of given matrix A exists. Okay, therefore here A inverse exists. A inverse exists. Now we go with inverse of given matrix A, and we find this inverse by using elementary transformation, that is by using the row transformation. We use row transformation here. If we have to use row transformation, then we consider the equation. Consider equation, and is A inverse is equal to identity matrix. Again, this I is having order 3, since here A is having order 3. Since A is having order 3. So here we replace our A by using given matrix. Okay, here given in first row 0, 1, 2. Then in second row here 1, 2, 3. Then in last row here 3, 1, 1. Into A inverse is equal to, again identity matrix of order 3 is like here 1, 0, 0, then 0, 1, 0, and for last row 0, 0, 1. Remember. Now we have to reduce this given matrix A to identity matrix, and here identity matrix is like this. Okay, now here in the for the first position we want 1. So we have to reduce this 0 to 1. We have to consider in the position of 0 as 1. Okay, and to make this we interchange our first and second rows. We interchange our first and second row. So here R1 double implies R2, that is we interchange row first with row second. So here inside the matrix, here in the position of first row, we consider elements of row second, that is 1, 2, 3. Now for the position of row second, we consider elements of row first, that is 0, 1, 2. Then here last row as it is, into A inverse is equal to, here remember, here we perform the transformation only on A and in RHS, not on A inverse. So here again we replace first row by using elements of row second, that is 0, 1, 0. Then for the position of row second we consider elements of row first, that is 1, 0, 0. Next here we keep third row as it is, that is 0, 0, 1 as it is. Now here we get 1. In the position of 0 we get 1. Now in next step we have to reduce this 1 to 0, since in the position of A to 1 we have 0. Here already we have 0. So we go with our next step. Here in the position of 3 we want 0, since here 0 is given. And to make this 0, we perform the transformation. Okay, here change is in row 3. Here change is in row 3, and change is, here R3 minus 3R1. That is, we multiply each element of row first by 3 and we subtract this from elements of row 3. Okay, so here in the matrix, again we keep our first row as it is, that is 1, 2, 3 as it is. Next, here second row having 0, 1, 2, we keep this as it is. Here change is in row 3. Okay, so here first element from row 3 is 3. Then with minus 3, here first element from row first is 1 and we know 3 minus 3 is 0. So here in the position of 3 we have 0. Next, here second element from row 3 is 1 with minus sign, here 3 into bracket. Second element from first row is 2. So here we get 1 minus 6. We know 1 minus 6 is minus 5. So in the position of 1, here we have minus 5. Similarly for third element, here third element of row 3 is 1 with minus 3. Here third element from first row is 3. Here we get 1 minus 9. We know 1 minus 9 is minus 8. So here in the position of 1, we have minus 8. Okay. Here A inverse as it is. Now similar transformation, same transformation. We perform the same transformation in RHS. Here again, first row, we keep first row as it is. Here second row having 1, 0, 0 as it is. Now transformation is on third row. Okay. Here first element from row 3 is 0. With minus 3, here first element from first row is 0. So here we get 0. So for this position of 0, here we have 0. Next, here second element from row 3 is 0. With minus 3, here second element from row first is 1. We know 0 minus 3 is minus 3. So in the position of 0, here we have minus 3. Next, here last element from third row is 1 with minus 3. Here last element from first row is 0. We get here 1 minus 0 and 1 minus 0 is 1. So here we have 1. Okay, so in the position of 3, we consider 0 by using this transformation. Now in the next step, here in the middle position, that is in the position of A2, 2, we want 1. Here already we have 1. Now we go with next step. Here in the position of A1, 2. Here in the position of A1, 2, we want 0. Here we have to reduce this 2 to 0. And to reduce this to 0, we consider the transformation. That is, we change in, here change is in row first and change is here row first minus 2 times row second. That is, we multiply each element of row second by 2 and we subtract this from row first. Okay, so here inside the matrix, now here first element from row first is 1. Next, with minus 2, here first element from row second is 0. So this is equal to, we know 1 minus 0 is 1. So here in the position of 1, we have 1. Next, here second element from row first is 2. So 2 minus 2 into. In the second row, second element is 1. Okay, we know this 2 minus 2 is 0. So here in the position of 2, we get 0. Next, here again last element from this row is 3. Then with minus 2, here second element, last element from second row is 2. Here we get 3 minus 4. We know 3 minus 4 is minus 1. So here in the position of 3, we get minus 1. Now here we keep our second row as it is, 0, 1, 2. Again in the next step, here in the position of A32, Here in the position of A32, we want 0. That is in the position of -5, we want 0. And to reduce this 0, we perform the transformation here. Here change is in row 3 and change is here row 3 minus 5, sorry, plus 5R2. Okay, we multiply each element of row second by 5 and we add this with row 3. That is change is in row 3. Okay, so here consider first element. First element from row 3 is 0 plus 5 into first element from row second is 0. So in the position of 0, here 0. Next, here second element from row 3 is -5. Then with plus 5, here second element from row second is 1. This is equal to, we know -5 plus 5 is 0. So here in the position of -5 we get 0. Next, here last element from row 3 is -8 with plus sign plus 5. Here last element of row second is 2. Here we get -8 plus 10. We know -8 plus 10 is 2. So here in the position of -8 we get 2. Then here A inverse is equal to, now for the first row we perform the same transformation. We perform this transformation. Again here in the position of row first we have 0 with -2. Here first element from row second is 1. So we get 0 minus 2 and is -2. So in the position of 0 we get -2. Next, here second element from row first is 1 with -2. Here second element from row second is 0. So we get 1 minus 0 and we know 1 minus 0 is 1. Here we get 1. Next, here last element from first row is 0 with -2. Here last element from second row is 0. Here we get 0 minus 0 and we know this is 0. So in the position of 0 again we have 0. Now here we keep second row as it is, 1 0 0. Now change is in row 3 and change is row 3 plus 5R2. Okay, we multiply each element of row second by 5 and we add this with our row 3. So here, okay, we consider row 3. First element from row 3 is 0. Then with 5 plus 5. Here, first element from row second is 1. We know 0 plus 5 is 5. So here in the position of 0, we get 5. Next, here, second element from row 3 is -3 with plus 5. Here second element from row second is 0. We know here -3 plus 0 is -3. Okay, so here in the position of -3 again we have -3. Here again we have -3. Next, here last element from row 3 is 1. Okay, then with plus sign plus 5. Here last element from row second is 0. So we get 1 plus 0 and 1 plus 0 is 1. So here in the position of 1 again we have 1. Okay, so we reduce this 2 to 0 and this -5 to 0. Now in the next step here we reduce A33 to 1. Since here in the position of A33 we have 1. So here we have to reduce this 2 to 1 and to make this 1 we divide the row 3, we divide the row 3 by 2. That is, we divide each element of row 3 by 2. Okay, so here, okay, we perform the transformation on row 3 and transformation is here row 3 divided by 2. That is, we divide each element of row 3 by 2. So, here in first matrix, we consider our first row and second row as it is. That is, in the first row, 1, 0, minus 1. In the second row, 0, 1, 2. Then, for the third row, we divide each by 2. We know 0 upon 2 is 0. 0 upon 2 is 0. So, here 0 and 0. For last element, 2 upon 2 is 1. Then A inverse is equal to, here again we keep first row and second row as it is. That is, here minus 2, 1, 0 in first row. Then for second, here 1, 0, 0. Next, here we divide each element of row 3 by 2. We get here 5 upon 2. Then minus 3 upon 2, and in last here 1 upon 2. Okay, so we reduce these 2 to 1 here by using the transformation. Now here we have to reduce this A13 and A23 to 0. That is, we have to reduce this minus 1 to 0 and this 2 to 0. And to reduce this, we perform the transformation. Firstly, we go with this minus 1. We reduce this minus 1 to 0. Okay. So here, to reduce this, we add. Okay. Here, change is in row first, and change is here row first plus row 3. Since here, minus 1 plus 1 is 0. Okay. So here, in the first row, okay, 1 plus last first element from last row, that is 1 plus 0 is 1. Next, 0 plus 0 is 0. Next, here minus 1 plus 1 is 0. Now we perform next transformation on these 2. We have to reduce this 2 to 0. And to reduce this, we use, that is here change is in row second, and change is here row second minus 2 times row 3. That is, we multiply each element of last row by 2 and we subtract this from row second. Okay. So here 0 minus 0 is again 0. Then 1 minus 0 is again 1. In the last, for the last element from second row, consider 2 minus 2 times. Last element from row 3 is 1. We know 2 minus 2 is 0. So here in the position of 2 we get 0. Now we keep our last row as it is. Here 0, 0, 1 as it is. A inverse is equal to, then in RHS. In RHS again, for the first row we perform the transformation and is R1 plus R3. R1 plus R3. Okay. So here given minus 2, then first element from row 3 is 5 by 2, so minus 2 plus 5 by 2, and is minus 4 plus 5 upon 2, and we know this is 1 upon 2. So here in the position of minus 2 we get 1 upon 2. Okay. Next, here second element from first row is 1. Then with plus sign, here second element from row 3 and is minus 3 upon 2. Okay. This is equal to, here we get 2 minus 3 upon 2 and we get minus 1 upon 2. So here in the position of 1 we get minus 1 upon 2. Next, here row first, element from row, last element from row first is 0 plus last element from row 3 is 1 upon 2 and we get 1 upon 2. So here in the position of 0 we get 1 upon 2. Okay. Now here change is in row second. Here first element from row second is 1 with minus 2. Here first element from row 3 is 5 upon 2. So this is equal to, we get 1 minus 10 upon 2. is equal to 1 minus, we know 10 upon 2 is 5, and here we get minus 4. So here in the position of 1 we get minus 4. Okay, next here second element from row second is 0, then with minus sign 2 into, here in the second position of row 3 we have minus 3 upon 2. Okay, here we get plus 6 upon 2, we know 6 upon 2 is 3. Okay, so here in the position of 0 we get 3. And in last, here last element from second row is 0, then with minus 2, here last element from row 3 is 1 upon 2. Okay, and this is equal to minus 2 upon 2 and is equal to minus 1. So in the position of 0 we get here minus 1. We get here minus 1. Okay, so here we keep third row as it is, 5 upon 2 minus 3 upon 2, this 1 upon 2. So we reduce our given matrix A to identity matrix, and to reduce this we perform the row transformation. We perform the row transformation. Okay, so we get form here I A inverse is equal to matrix having elements 1 upon 2, minus 1 upon 2, 1 upon 2 in the first row. For second, minus 4, 3, minus 1. For third, here 5 upon 2, minus 3 upon 2, 1 upon 2. Now we know I into I inverse is, I into A inverse is again A inverse and is equal to, here inside the matrix elements are 1 upon 2, minus 1 upon 2, here 1 upon 2 in the first row, then minus 4, 3, minus 1 in the second row, then for last here 5 by 2, minus 3 upon 2 and 1 upon 2. This is the inverse of given matrix A. And we find this by using row transformation. Okay, in today's lecture, we see two examples related with how to find the inverse by using the row transformation. In next lecture, we find inverse of given matrix by using column transformation. Thank you.